Welcome everyone. Today I will be presenting the software security analysis of a web application called iTECH. Here is the contents of my video presentation. It includes an introduction part, cross-site scripting, SQL injection, vulnerable JavaScript library, and Google OAuth 2.0 implementation part. First, let's see what is iTECH. iTECH is used to manage mobile repair operations, track services, handle inventory, and improve customer satisfaction. Because it handles sensitive information and business operations, ensuring its security is critical. First, I found a cross-site scripting no XSS vulnerability. This occurs when an attacker can inject malicious JavaScript into a web page. In our case, the index.php file directly loaded user input without validation. For example, if someone entered a malicious URL, they could pop up an alert or even steal sensitive session data. To fix this, I implemented a whitelisting technique, only allowing a list of safe pages that can be loaded. This completely prevents attackers from injecting unexpected page or scripts. Next, I discovered a SQL injection vulnerability. SQL injection is a type of security attack where an attacker inserts malicious SQL code into an input field, like a URL or form, to manipulate the database. In viewStatus.php file, the user input code was directly inserted into SQL query without any filtering. An attacker could input something like or 1 equal 1 and bypass authentication or view unauthorized data. To solve this, I used prepared statements with placeholders. This ensures user input is treated as data, not as part of the SQL command itself, completely blocking injection attack. I also found a vulnerability related to a JavaScript library. The JavaScript library is movement.js used for data handling. Older versions of this library had issues like denial of service attacks and path traversal exploits. To fix this, I updated the movement.js library to the latest secure version 2.30.1, which is patch all known vulnerabilities. Another SQL injection issue was found in viewDetails.php file. User input was directly embedded in the SQL query without any checks. This made the system vulnerable to attacks that could either bypass security or delay server responses. I fixed this by using prepared statements and properly binding the parameters. Finally, to improve authentication security, iTECH uses Google OAuth 2.0. Instead of managing password ourselves, users can log in securely using their Google accounts. I explained the flow clearly. The login page displays a Sign in Google button. The button redirects the user to Google's login screen using the OAuth URL from Google Client Setup PHP. This Google Client Setup.php file initializes and configures the Google API client, which includes client ID and secret. The system redirects users to Google's login page. After login, Google redirects back to our application. Actually, Google redirects to Google login callback.php file. After successful login, Google redirects the user to this callback file with an auth code. This file exchanges the code for an access token, get the user profile info, save them in a PHP session, and finally redirects the user to index.php. Index.php file loads after authentication is successful. Then the app can now read session data to confirm the user is logged in. The app fetches user details like name and email and stores them securely in a PHP session. This flow enhances security by avoiding password storage and relying on Google's trusted authentication system. In summary, through these security improvements, fixing excesses, preventing SQL injection, updating vulnerable libraries, and implementing secure OAuth login, the iTECH web application has become much more robust and secure. Thank you very much for your attention.